Hello students, welcome to my class on computer graphics. Today I will discuss the 3D projection. Basically this is the continuation class. I am Shravani Kundu, Assistant Professor, Department of Computer Science and Engineering, Guru Nanak Institute of Technology. After going through this class, you will be able to understand the different types of projection and how this projection is required in our real life. Now, in the last class, I discussed that 3D projections, and those are the different classification of 3D projection, that is parallel projection, perspective projection, and parallel projection again are of two types: orthographic projection, oblique projection. Orthographic projection can be divided into three categories: top view, front view, side view. And oblique projection can be divided in two categories: cavalier projection and cabinet projection. Now the perspective projection is again divided into three categories: 1 point, 2 point and 3 point. Now first I will discuss orthographic projection, and then I will show you how the orthographic projection is different from the oblique projection. So in case of orthographic projection, you can see over here that it is a type of parallel projection. So as I already discussed, that in case of parallel projections, the projectors, that means the projection line from the object, falls on the projection plane that in parallel, that means making the 90-degree angle. So that means if there is an object like this one, so consider there is an object, there is a straight line stick like this one, and what will happen in case of orthographic projection, in case of parallel projection, so this the straight line, so this red color which I have drawn over here, this consider this is a straight line, and those lines which is drawn by the brown colors, those are the projection line. So those projection lines are falling from the this starting from the object, and after passing through the object, it falls on a plane. Consider that is a projection plane. So here this is our projection plane. So this is, let us name it, this AB is the object, those are the projection line or projectors, and these projection lines falls on a plane. Consider this is our projection plane. So it falls on a plane and creates the object like this one. Okay, so what happened over here? So while the projection lines are coming from the object, those projection lines are parallel to each other. So this is the basic properties of the parallel projection. Now orthographic projection is a type of parallel projection in which the projectors or projection line will meet at the infinity. Fine. And these projectors create a perpendicular. That means when those projectors falls on this projection plane. So as you know, this plane is called the projection plane. Okay, so when those projectors, so those lines are the projectors, so when they fall on the projection plane, they create the 90-degree angle. Fine. So this type of projection is called the orthographic parallel projection. Now here you can see another example, that there is a cube, and let us assume that this is our x direction, this is x-axis, this is our y-axis, and this is our z. Fine. Now while you want to project the object on any 2D plane, so either this plane may be xy plane or xz plane or yz plane. So what are the possible combination, possible planes are there? So in case of, so this object is in 3D domain, 3D dimension. Now if I want to project that object from 3D dimension to the 2D dimension, then I can project the object either in the xy plane, or I can project that object on xz plane, or I can project the object on yz plane. Fine. Now if you want to project the object on the xz plane. So what is my xz plane? So this plane is my xz plane. Okay, so you can see that in the xz plane the value of y coordinate is 0. So if I observe from this point, from this, so suppose our eyes is over here, so this is, there is my our eyes from where we are seeing. So if I observe from top of the object, then what we can see? We can see that a square-like shape will be formed on the xz plane. So this square-like shape will be formed on the xz plane. Fine. So in this square-like shape, the value of y-axis is 0. Okay, the value of y coordinate is 0. Similarly, if you observe from this direction, if this is a direction of observation, take some another color. So this, if you observe from this direction, so the object will be projected on this plane, and here you can see that on this plane, let me draw it. So on this plane the object will be projected, and something like this one, this will be created on this plane. Okay, so this image will be created on yz plane. So if you observe from this direction, so let us name the put some name on the direction. This is the direction P, this is the direction Q. So if you observe from the direction Q, so you can see this image, this one, on the yz plane. Fine. So that means in the yz plane, why this object will be square will be projected on the yz plane. So in the yz plane, the value of x coordinate is, all the values of x will be 0. Similarly, if you observe from this direction, fine. So if you observe from this direction, so let us say this is r direction. So for the, if you observe from this one, then the projection of this particular object will be generated in the xy plane, and let us say that the projection will be something like that. So this is our projected object on the xy plane, and in this projected object you can see that here all the points will be represented in terms of x and y. The value of z coordinate is 0. Fine. So far you can understand that if I project an object from 3D domain to the 2-dimensional domain, so either we can project it in the xy plane or xz plane or yz plane. Fine. So if you project it on the xy plane, in that case the value of z coordinate is 0. So that means the value of z will be 0. If you project it in the xz plane, the value of y will be 0. But if you project in yz plane, then value of x will be 0. Fine. So how we can convert this? So if any object is given and the coordinate of the objects, that means some points are given. So by using those points and using some transformation matrix, you can transform that object in any one of the domain. That means you can create the projection of that object in any one of the plane by using the transformation matrix. Okay, so let us write down the transformation matrix for the xy plane. Fine. So the transformation matrix for the xy plane, so let us rename it px. Px is the transformation matrix for the let us say px is the transformation matrix for yz plane, because your value of all x axis is 0. So in that case the transformation matrix will be like this one. So as the value of all x's is 0, so this is as you know that this is x, this is y, this is z, and this is a weight factor. Okay, so here value of all x's will be 0. Fine. So and similarly this will be also 0. So let us write down it once again. So it will be something like that. This is 0 0 0 0. and this is also 0, 0, 0. Fine, this is xyz, this is xyz. I have just wrongly written. It will be like this one, xyz, and this is a weight factor. It is not in the, I am writing in the column measure ordering, not in the row measure ordering. So if it is xyz, so that means 0, 0, 0, 0, all xyz will be 0, all x's value will be 0, and the value of y and z, it will be 1, 0, 0, 1, 0, 0, 0, 0, 0, 1. Okay, so let me write it clearly. This is 0, this is 0, 0, and 1. So this is the transformation matrix to create the projection on the YZ plane. Okay, now similarly, if you want to project in XZ plane, in that case the value of y coordinate will be 0. Fine. So in that case, if you want to project in the XZ plane, so the projection matrix or transformation matrix will be PY, and this PY will be written like this one. So as value of all y's are 0, so it will be written like this one, 1, 0, 0, then 0, 0, 0, 0, then 0, 0, 1, 0, 0, 0, 0, 1. Okay. So this is a projection matrix. If you have a set of points of any object, by multiplying this projection matrix with that points or point matrices matrix, you can generate the coordinate for the projected object. Fine. Now let us write down another projection matrix, PZ. So in PZ means the projection will be generated, projection will be formed on the XY plane where the value of all z's are 0. Z coordinate is 0. Okay. So the projection matrix in the XY plane will be like this one, 1, 0, 0, 0, 1, 0, 0. All the z coordinates will be 0. So this row is 0, 0, 0, 0, 0, and this is a weight factor. Fine. So if you have set of points, then in that case, by multiplying the points with any projection matrix, you can generate the corresponding projection in any plane. So either in the XY plane and YZ plane or XZ plane. Fine. Now this is called the orthographic projection. Now here, as you know, that orthographic projections are of different type. Fine. So this is called the side view, front view, and top view. So if you observe this particular image, so in this image you can see there is an object, and this red arrow indicate that you are viewing the object. You are viewing the object from the top of the object. So as I have shown over here. So P is a point from where you are viewing the object. So we assume that this is the top of the object. That means we are viewing the object from the top, and we can then convert that object in the 2D plane. So if you view from the top, that means this portion will not be visible to you. You can see only this particular portion, and you can see this portion. So the remaining portions are not visible. So that means if you view from the top of the object, the view will be like this one. You can view the 2D transformation of this 3D object. If you project it from the top side, then after projection, it will generate the image, the projection of the image like this one. Okay. Now, if you view the object from the front, fine. So front is this one. So this is our front. So if you view from this plane, so which surface you can view? You can view only this surface, and you can view only this surface. So that means this projection will be created for this particular object if we view from the front. So this is called the front view. Fine. Now, if you view from the side, okay, so this is our side, the arrow which is indicated by purple. So this is our side view. So let us write down the name. This is a top view, this is a side view, and this is a front view. So if you view from this direction, you know only this surface, on this surface will be visible. So that means you can see an image, projected image on the plane, and the shape of the projected image will be something like this. Okay, so this is called the side view of the projection. Fine. So in the here you can see there are different types of projection. One is a parallel projection and perspective projection. In case of parallel projection, there are two types of projection: orthographic projection and oblique projection. Orthographic projection again are of three types, which is side view, front view, and top view. So this classification of the orthographic projection is based on the direction from which we are viewing the object, and based on the viewing direction, the projected image will be created on the projected plane. Okay, so that is all about the orthographic projection. Now next we will discuss the oblique projection. Now in case of oblique projection, you can see that this is our projection plane. So this AB is our projection plane, and there is a point, let us say P. Okay, now while we are discussing the orthographic projection, the projectors or projection line is coming directly from the point P, and it falls on the projection plane by creating an angle which is 90 degrees. Fine. But in case of oblique projection, while the projectors or projection lines are coming from the point P, it falls on the projection plane, which is AB. While it is falling on the projection plane, it creates an angle theta, which is not 90 degrees. So this type of projection is called the oblique projection. Okay, so I think it is clear. In case of orthographic projection, the projectors falls on the plane by making an angle 90 degree. But in case of oblique projection, the projectors falls on the plane by making an angle theta, which is not 90 degree. Fine. Now this oblique projection has some different projection matrix. So let us discuss how we can generate the projection matrix, the transformation matrix for the oblique projection. Okay, now consider this diagram over here. So you can see this diagram. Now in this diagram you can see that there is a point which is called P. Fine. Now from this P, the rays are coming, that means the projection lines or projectors are coming from the point P. This is not the perspective projection, this is under the parallel projection. So from the point P, the projection lines are coming and it is falling on the projection plane. So this is our, this plane is called the projection plane. Fine, it is falling on the projection plane. Now while it is falling on the projection plane, it's creating an angle which is called the alpha. Okay, but if the projectors falls on the projection plane by making an angle 90 degree, in that case it should it should follow this line. Clear? So again I am telling that suppose there is a point P, the projectors are coming from the projection lines are coming, passing from the point P, and in case of oblique projection, it falls on the point Q. Okay, so PQ is the projectors, that means the projection lines which is coming from the point P, and it falls on the projection plane Q by making an angle alpha. But that happens only for the oblique projection. But in case of perspective, in case of parallel projection, that is in case of orthographic projection, this point, is the projectors which is passing from the point P falls on the point R on the projection plane by making an angle 90 degree. Fine. Now, what we have to do? We have to understand, we have to find out what is the angle alpha. Fine. Now, and we also have to find out the point XP and YP. So you can remember that oblique projections again are of two types. So one is called the Cavalier projection and second one is called the cabinet projection. Fine. So first one is called the Cavalier projection and second one is called the cabinet projection. Now, first we are discussing the Cavalier projection. Okay. Now, in case of Cavalier projection, this angle is treated as 45 degree. I am coming later. The angle alpha will be 45 degree, but in case of cabinet projection, this angle alpha will be something else. Now, our major objective, is we have to compute the point XP, YP. XP, YP is the projected point, where the coordinate of the point P is XY. So P, XY is the original point and we have to compute the projected point on the projection plane, which is XP, YP. So this XP, YP we need to compute. Now how we can compute? Okay. Now you can see if we can join this line Q and R, so let us say the length of this line is L. Okay. Now, this angle is alpha. This angle is 90 degree. And if this angle is alpha, then we consider there is another angle, this line, which is phi. And this angle phi is formed with the help of the line RQ and the line which is parallel to the x-axis. So you can see this line is parallel to the x-axis. So this angle phi is formed with the help of the line RQ and a line which is parallel to the x-axis. Fine. Now, what is our XP? So if we can draw a perpendicular on this from the point Q. So if we can draw a perpendicular from the point Q on this line. Okay. So make it quite dark. So this is a line. So definitely you can understand that if this point XY falls on this point R, so in that case, this will remain XY in case of orthographic projection, because this point P is in the three-dimensional domain. So apart from XY, there is another point Z. So when it falls on the XY plane, let us say, okay, this is XY plane. So when it falls on the XY plane, only the Z part will be removed and Z part will be 0. So the coordinate will still remain XY. Now, what we have to do, we have to compute this XPYP, and to compute the XPYP, what we have to do, we have to consider this triangle QR and S. Okay. Now, if we can compute the distance RS, then by adding RS with X, we can compute XP. Okay. So let us write down it. So what will be my XP? My XP will be X plus the length RS. Similarly, the YP will be the Y, this value, and the length QS. Okay. So our objective is to find out the length RS and QS. And we know the distance from R to Q is L. Okay. Now, so what will be my RS? Our RS will be this. RS will be, if you consider this angle is phi, so it will be, we can write down it in this way. This length is L. That means the length of RQ is L. So we can write down RS divided by RQ is equals to cos phi. Okay, we know that RQ is L, so we can write down RS equals to L cos phi. So we can substitute this in this equation and we can write down XP equals to X plus L cos phi. Fine. Similarly, we also can compute the QS. So what is QS? We also can write down that QS by RQ is equals to sin phi. So, and you know that RQ is equals to L from this equation. So what we can write down? We can write down that QS equals to L sin phi. So if I substitute that QS equals to L sin phi in this equation, we can write YP equals to Y plus L sin phi. Okay. So in this way we can compute the XP and YP. Okay. So now if I write down it in terms of the equation, we will write it like, so we can write it like XP is equals to X plus L cos phi, YP equals to Y plus L sin phi. Okay. Now there is another important observation which you can see, that we know that this is our L. Okay. And we also can, if this angle is alpha, this is an alpha, so this projector, that means this projection line which is coming from the point P, what are the length it is traversing? This is a plane. Okay, try to understand. This point P belongs to a plane, and why it falls on over here, so it has to traverse the length which is with the amount z. That means if the coordinate of the point P is xyz, and if the same point P falls on this plane, and if after falling on this xy plane, if the coordinate becomes xp yp 0, that means what is the length from P to Q? The length from P to Q is z. Okay, so this will be z. Okay, just a minute, not this one, this length. Okay, this length will be z. I'm making it wrong. So this xy is falls on the xy plane. This point P is projected on this xy plane, and it is traversing the distance z. So this length PR is z, not PQ. This length PR is z. Okay, we know this length is QR equal to L, but we don't know the value of L. That is a problem. We have to substitute by L some known factor. So what from this equation, what you can write, this is a Z, this is a L. So we can write down that Z by L is equals to tan alpha. Okay. So what will be my L? L will be Z cot alpha. Okay. So what we will do over here, we will replace this L, okay, by the Z cot alpha. So if you replace the L by Z cot alpha, then you can compute the XP and YP. So in this way, you can compute the coordinate of the projected point in case of oblique projection. Now, what is the difference between cavalier projection and the cabinet projection? The difference between the cavalier projection and cabinet projection lies on the angle of alpha. Now, if the value of alpha is, 45 degree, in that case, we can create the cavalier projection. But in case of cabinet projection, the value of alpha is, so I'm just writing it, in case of cavalier projection, value of alpha is 45 degree. But in case of cabinet projection, the value of alpha is something, is near about, it is not equals to, it is near about 63.4 degree. You can prove it. Okay. So while we project the object using the cabinet projection, you can find that it will be more realistic compared to the cavalier projection, because once if you project using the cavalier projection, it creates the projection in such a way that in the projected image, the length of the projected image will be same as the original image. So it doesn't create any realistic view. But while we will project by using the cabinet projection, it will create a more realistic view. So as you can see that there are two diagrams are given. So the object is projected. The first one is using the cavalier projection and the second one is using the cabinet projection. Fine. So in case of cavalier projection, the projection is not that much realistic considering the cabinet projection. Fine. So that is a major difference between the cavalier projection and cabinet projection. So that is all about the different types of projection. So perspective projection I have already discussed in my previous lecture, and in case of the parallel projection, there is two classification, orthographic and oblique. Orthographic is while the orthographic projection will be created while the projector will create the 90-degree angle with the projection plane. But in case of oblique projection, the projector will create some angle which is alpha, which is not 90 degree. Based on this angle alpha, there are two types of projection. One is a cavalier projection and second one is a cabinet projection. In case of cavalier projection, this alpha is equals to 45 degree. But in case of cabinet projection, this alpha is near about 63.4 degree. Okay. So that is all about the projections.